All right, so this section we're going to break up into two different videos. It should be fairly short, but we're going to break up into two different videos. The first one that we're going to discuss is going to be the perpendicular bisector theorem and its converse. All right, so the first thing says if we have a line, in this case we have this line here that I'm going to draw blue. So we have this line. So if we have a line that is another segment's perpendicular bisector, and we know it's this segment's perpendicular bisector because it tells us it's perpendicular with the right angle, and then it tells us that it divides it into two equal parts. So we know that this blue line, this line PM, is the perpendicular bisector to segment AB. So if we have a line that's a perpendicular bisector, then we know that the distance from that point P is the same to the two endpoints. So that means the distance from AB is equal to the distance to PB. So I'm sorry, the distance from AP is the same as the distance from PB. All right, so once we know that that line is part of its perpendicular bisector, then that point P is the same distance to A and B. And now that works if we were to change that point P and move it anywhere about. So if we were to change and ask for this point here, and let's label that X. Well, that means the distance from AX is the same as it is from XB. All right, so any point on that perpendicular bisector, whether if it's here, down here, any point is the same distance to the two endpoints. All right, so that is the perpendicular bisector theorem. And now the converse of that, now remember when we deal with the converse, we switch the hypothesis and the conclusion. So that states if we have a point, in this case we have point P, and we said it's the same distance to the two endpoints, then it guarantees that that point P is on its perpendicular bisector. So that means we can draw this line here, and we know it's going to guarantee that it will fall on that perpendicular bisector. All right, last year, I'm going to scroll down a little bit. All right, so when we have that point P, if it is the same distance to the two endpoints, then it guarantees that it's on its perpendicular bisector. So if PA is equal to PB, then we know it's its perpendicular bisector. Right. Last year, some kids had a hard time with this. So what they were saying, if I give you this segment AB, and I have this point P, and I tell you that PA is congruent to PB. Now, what this theorem states is it guarantees that that point P will fall on the perpendicular bisector. It doesn't mean that the only line that you can draw through is its perpendicular bisector, but it guarantees that that will 100% happen. Right? So if you really wanted to, I'm going to draw this in a purple line. Right? So if you really wanted to, you can draw this line P intersecting our segment AB there, but that's clearly not its perpendicular bisector. So there's infinitely many lines that can still pass through P, but it guarantees that it will be on its perpendicular bisector. It doesn't mean that the perpendicular bisector is the only line, but it guarantees that it will be on it. All right, then we're just going to go through one example real quick. All right, so now we're going to do a couple examples. So they asked us, what is the length of AB? So we want to solve for what is the length of AB. Now, some of the information they give us is they say BD is the perpendicular bisector of AC. Now, I give you that in words this time just to help you out. But even if I didn't give you it in words, you know it is, because this here is saying that this D is our midpoint because these are two congruent segments, and it tells us that it's intersecting at 90 degrees, so we know that BD is its perpendicular bisector. So since it is, we know that the distance from A to B or C to B, we know that they have to be exactly the same because once it's on its perpendicular bisector, it's the same distance to the two endpoints. All right, so that means that AB is equal to AC. And then we just solve. So we can plug in 4x for AB, and we can plug in 6x minus 10 for AC, and now we just keep solving. We will subtract over 6x. Subtract over 6x, so negative 2x is equal to negative 10. And then we'll divide each side by negative 2, divide each side by negative 2, and we get that x is equal to 5. All right, but that's not what the question asked for. It says, what is AB? So we'll plug it in. 4 times 5, that is equal to 20. So we know that AB is equal to 20. All right, now you could plug it into the other one to make sure that it is correct. So 6 times 5 is 30, and 30 minus 10 is 20, so we know that we got the right answer. All right, and then the last problem is what is the length of QR? So we want to find what the length of QR is. All right, so that's this segment here. Same thing. They don't flat out tell us this time that this is our perpendicular bisector, but we know that that point S is our midpoint, and we know that it intersects at 90 degrees, so we know QS is the perpendicular bisector. So that means that PQ is the same distance as QR. Right? Then we solve. So PQ is equal to QR. PQ is equal to 3n minus 1, and QR is equal to 5n minus 7. We will subtract over 3n. We will add over 7. So then we get 6 is equal to 2n, divide each side by 2, and we get that n is equal to 3. All right, now once again, they didn't ask for what n is equal to. We want to know what QR is, so we plug it in. Now, we can plug it into either one of these. It really doesn't matter. We'll plug it into both just to ensure that we got the right answer. But 5 times 3 minus 7, 15 minus 7, or 8. So QR is equal to 8. And then 3 times 3 minus 1, 9 minus 1 is 8. So we know that we got the right answer because both of them are congruent. All right, and that is it for this video.